The difference quotient is a little sample of calculus. We use it to measure the rate of change between 2 points on a curve. Let's develop the formula. If we look at a graph of some function, let's call it y equals f of x, the difference quotient will find the rate between any 2 points, even though this is a curve. So, for example, if we choose a point right here, what are the coordinates? We're not going to introduce any numbers into this problem. We're just going to use variables. Well, directly below that point, we're going to say we have a point x. And if we plug that point into f of x, then the y coordinate turns out to be f of x, right? Now let's pick another point. Let's say we have a point right here. Instead of calling that a different variable, we're going to use the distance between these 2 places on the x-axis. We're going to say that the distance between them is h. So if the distance between them is h, then this second point must be x plus h more. And its y coordinate must be what we get when we plug in x plus h into f. So now we have 2 y coordinates and 2 x coordinates, and we are going to use these expressions in the formula. The formula is measuring the rate of change between these 2 points. If you straighten it out, well, that looks a lot like slope, right? So we're going to start with slope formula. You remember that? I'm sure you do. We always used y2 minus y1 divided by x2 minus x1. So let's use that here, except let's use these expressions. My second y coordinate in this case is f of x plus h. And we're going to subtract the first y coordinate, which was f of x. All right, the second x coordinate is x plus h. And from that, we're going to subtract the first x coordinate, which was just h. We can simplify this a little bit. Can't do anything in the numerator. So it's just f of x plus h minus f of x. But in the denominator, the x's cancel out, and we're left with just h. Now, since the denominator is just h, we do need to say that h can't be 0 in this formula. But what would that mean if it was 0? Think about it. Look at the graph. If h was 0, then these 2 points collapse into 1 point, and there's no point to finding the rate between 2 points if it's only 1 point. So h equals 0 is a meaningless case, and you can see why that doesn't work for this formula. All right, now let's try to use it. In this course, we're going to practice setting it up for different functions and simplifying it a little bit so that we get a simplified version of a formula for the rate between 2 points in a curve. When you get to calculus, you're going to learn more about why this is such an important concept. But by practicing it now, you'll master that concept much faster when you get to calculus. And for now, it's really good practice with your algebra skills anyway. So that's mostly what we're going to be doing. Let's try to set it up using this function. F of x equals x squared minus 1. This is always a quotient, so start with that. Remember that we're always going to do f of x plus h first and subtract f of x from that. And in the denominator, all we have is h. So in this case, I always like to put parentheses around the x's so that you remember that distribution and squaring are all affected by that. So when we plug in x plus h into this function, then we get x plus h squared minus 1. I'm going to put brackets around that for now. We're going to subtract from that f of x, which is just the function that you see, x squared minus 1. But if I don't put parentheses around that, I'm going to have a distribution error. So make sure that you put that in parentheses. All right, and in the denominator, we just have h. We have a lot of simplifying to do in the numerator, and that's mostly what you're going to be doing in your homework. So let's work on this. Focus on the exponents and the distribution. X plus h squared is an easy binomial square, right? So just x squared plus 2xh plus h squared. And we still have minus 1 out there. And then we need to distribute negative 1 to the second binomial. So I get negative x squared plus 1. And that is one of the most missed concepts in algebra and algebra 2 and pre-calculus, is forgetting to distribute to the subsequent parts of a polynomial. Underneath all of that, we still have h. Okay, what can we simplify here? Well, we've got an x squared and a negative x squared, so those disappear. And we've got a plus 1 and a minus 1. Those are gone. So let's see what's left. We have 2xh plus h squared. And that's all over h. Now, if you're feeling that urge to reduce, you need to be very careful, because this is the other most missed concept in algebra. The only way that you can reduce that h in the denominator with the numerator is if you can factor h out of the numerator first. So let's try that. H is a common factor, so I'm going to take it out of both terms in the top. And now that h is a factor of the numerator, it can be reduced. And so our simplified form of this formula is just 2x plus h. That's all that's left. Now, what's the point of that? That is a simplified formula for the rate of change between any 2 points on the graph of f of x equals x squared minus 1. That is the difference quotient for this f of x. You're going to see a lot of different functions in your homework, and that's what you do with them. Go try it.